Motor types. In this video, we'll be covering various types of e-bike motors and their pros and cons, why it matters, to know the capabilities of each motor and see how they work, and its fundamental knowledge for problem solving. Prerequisite VODs, the ones on watt, amp hours, and watt hours, and motor anatomy. There's many various different motor types on e-bikes, but the most common ones you'll come across are direct drive hub motors, geared hub motors, and mid drives. You may see some friction drives, left side mid drives, or tube mounted drives, which we will cover briefly. Direct drive hub motors. A DD hub motor is a large outrunner with no internal gearing, and the wheel is the rotor itself. The gear ratio is 1:1. Now these hub motors have the most raw power potential but no gearing, so they can't multiply their torque. Think of it like a fixie bike that has a single gear and it cannot be geared down to climb hills. Now these motors are medium to heavy, typically 5 to 20 kilos plus, and they create a lot of unsprung mass. So what that means, if you're going over bumps or potholes, unless you have nice big plush tires or rear suspension or a suspension seat post, you can really feel the impact or the bounce of these motors. Now these motors are the cheapest to produce because the least number of moving parts, and the maintenance is little to none, especially if you have the correct spoke gauge and tension, correct torque arms, and the plate or the motor face is silicon sealed to help prevent water ingress or dust ingress. Extra notes, this motor has regenerative braking inbuilt. You require no modifications, just a compatible controller to use regen. The ideal power class I've found for this motor is between 3000 and 20,000 watts. It doesn't really shine at the lower power classes where you see many different e-bikes just because that gear-to-gear fixed ratio of 1, where you can't multiply the torque at low power. If this motor is being used at a state where it's underpowered, it really sucks at climbing hills. But with the right design, you can overcome that limitation just by dumping a whole bunch of power into it, therefore leading to its ideal use case, high power, with cargo bikes and commuters. Geared hub motors. They are a medium-sized outrunner motor like a direct drive, but with one stage of gear reduction. The gear ratio for these is typically 5:1 or 4:1. That means every time the motor spins 4 or 5 times, the wheel on the bike will turn once. The mechanism that enables this is an internal planetary gear with a Sprag one-way clutch, allowing the motor to coast without resistance but engage when the motor is driving the wheel. The weight on these systems, it's light to medium, typically less than 5 kilos. The cost, cheap due to common mass production. These are, after all, the most common type of hub motors that you'll see. Maintenance, quite low if the correct spoke gauge and tension is used with torque washers, and the motor is correctly sealed and the gears have the right amount of grease. Extra notes, regen, no, unless you do some crazy modifications by essentially welding the Sprag clutch in place. The gear ratio on this motor allows for a smaller size compared to a large direct drive motor. Its ideal power range is usually between 0 to 3000 watts. Any higher than that, then you'll start to overheat the motor or destroy the planetary gears, unless you do some crazy modifications. Just a quick update, consumer trends are pushing higher power systems. Some gear hub motors are emerging from various brands that are pushing past that 3000 watt threshold, but at the time of recording they are still quite rare. The ideal use case for this motor is low to medium power commuters, leisure trail and low cost e-bikes. Then we have mid-drive motors. They are a small-sized in-runner with a multi-stage gear reduction. The gear ratio on these can be huge, anywhere from 10:1 to 36:1. Basically, you have a very small high RPM rotor that spins very fast, and in doing so creates massive torque through all of these gears. Think of it this way: if you're on a mountain bike and you're extremely low hill climbing gear and you could pedal like 5 or 6 times faster than any human could, you'd have a pretty fast moving bike that could easily climb that hill. The weight of these motors is typically light to medium, usually less than 5 kilos, and it's centered and low, which has the best placement for mass on the e-bike. The cost? These motors are the most expensive because they have many different parts and they are the hardest to make. The maintenance can be extremely low, from like a Bosch e-bike motor, to quite high, whereas an early generation CYC motor, the later generations have got a lot better. It all depends on the design. Regardless, you're going to have increased drivetrain wear because there's going to be more pressure put on the chain ring and rear cassette of the bike. Extra notes: regen, no, not in this motor. Mid-drives can benefit even further from the e-bike's gearing, so you can increase this gear ratio even more using the standard e-bike gears. The ideal power range of the system is 0 to 6,000 watts. Any more than that, you start destroying bike components. The ideal use cases are cargo and hills at low power because the massive torque multiplying, and e-mountain bikes at low to high power. And lastly, let's briefly touch on a few other motors you may come across. There's friction drives, which acts like a gear where you have a spinning wheel that contacts the bike's wheel to force it to rotate. Now, friction drives typically have increased wear on the tire and can slip under high torque. That's why they're not commonly used. Left side mid drives. They're bulky, high power units, and you normally only see them on e-dirt bikes like the S1E18. Here's an example of a couple here. They normally have more than one gear reduction, but they have ridiculous amounts of power. And then finally, we have tuber mounted drives, which are low power, compact, discreet, or hidden. They're really only for those niche e-bikes that really do not want to look like e-bikes, and are therefore less common. Click here to watch the next video. It is the best free thing you can do to tell YouTube to support the channel. Otherwise, if you want to do more, check out the links in the description. Thanks for watching.